G'day team, and welcome back to yet another video on logs and exponentials, growth and decay. Together today we're going to look at how we're going to incorporate logs and natural logs into our growth and decay modeling that we looked at a few videos back. So I've got a nice example here, and we're going to look at the population of a pack of wolves. So our population function in terms of time t is 10 times by 1.13 to the power of t, where t is the time in years. Now you've got to pay special attention to the units given in a question, because they might throw in months or days and you've got to work it out and do the right ratio. So straight into it, what is the population after 3 years? That would be finding p of 3, so when time equals 3. So if I've replaced t in this equation with 3, I also have to do it to this t up here. So 10 times by 1.13 to the power of 3. Now if you throw that into your calculator, we get out 14.43. So we say that there's approximately, use an approximate sign, 15 wolves. Now we round up to the nearest whole wolf. Now, part B, use logs to determine how long it will take for the pack to reach 30 members. So, we've got our equation, population with respect to time is 10 times by 1.13 to the power of t. Now, we want the population to be 30, so we put that in for our p of t, just like this. And we want to solve this equation for t. So, let's get rid of this times by 10. We know we have to divide by 10. So we've got 3 equals 1.13 to the power of t, because I've got 30 divided by 10. Now, thinking back to our last video and solving exponential equations for unknowns, we want to take the log of both sides. Because there's no e involved, we used the regular base 10 log. Okay, so 1.13. I forgot the power of t, so let's put him in there. Now I know with my log laws, this t can come out the front. So I've got log of 3 equals t log of 1.13. And to get t by itself here, we divide by the log of 1.13. So I've got t is log of 3 all over the log of 1.13. Now, this comes out to be approximately 9 years. Okay, so approximately 9 years. Now, if you have a graphics calculator at home, I want you to graph this function, play around with the window and check B. I can't share my graphics calculator with you on my iPad, but I can show you on Desmos. So I've got my function here. I've got my population equal to 30, and the intersection will give me my time. And then we go 8.989, which is approximately 9 years, as we said before. So there's our little check. Hopefully this sort of shows you how logs can be used. We've done a whole heap of work with finding x given y, which is essentially what we're doing here, but we're now applying logarithms to it. Remember, if you see an e instead of a 1.13 or any other number, make sure you use your natural logs. All right, I'll see you guys in the next video.